Hello everyone. Today we are going to discuss about power electronics. Power electronics is an important module for power system engineers. So power system engineers are the one who is working in electrical substation or transmission electrical transmission system or electrical distribution system, even the nowadays microgrid implementations. And power electronics is important for power system engineers. So in this video we are going to explain why these power system engineers need to study power electronics on top of studying the transmission distribution, power generations, and power system analysis. These are the other subjects important. So power electronics is also important for them. Let's get into the more details. First thing, we have to understand what is the difference between electronics and power electronics. That's very fundamental. So we know that when we say electronics, we always think about diode transistors. Even in school days from year 6 or 7, we started to study about diodes and transistors, forward bias, reverse bias, all sort of things, and we do experiment in the school laboratory itself. Because you can simply understand these are low amperes, the current taking devices, low voltage devices, low voltage, actually low power devices. In laboratory we are giving some DC supply and we are testing, and with a very low voltage and current we can test these devices. But but when it comes to power electronics, it's a different scenario. We usually study power electronics only during the degree program when we go to university or colleges, campuses. So the reason is power electronics, we are dealing with very high voltage and high current applications. So we have a specific devices like SCR, MOSFET, those kind of devices that designed to handle about 1000 amperes, or let's say 500 amperes. So it's a huge current and a huge power rating. Even it can handle very high voltages. So these devices can be used in the transmission line or distribution lines. So let's assume, can we put a diode, simple diode, in a transmission line? Definitely no, because diode cannot handle even few amperes. In laboratory, in school laboratory, we have a diode transistors which usually burn when we give more power or some mistakes. It's usually burn and very easy to get damaged. The reason is those are low power devices. Okay, let's get into some explanation. Power electronics is a branch of electrical engineering that deal with the study, design and applications of electronic devices and circuits for converting and controlling electrical power efficiently. So the purpose of power electronics is about converting and controlling electrical power efficiently. It means we have to bring the power from one place to another place or distribute the power. So the purpose of power electronics devices is to uh, provide support for this transmission of power, transmission and distribution of power. When it comes to simple electronic devices, there are many other applications like TV, mobile phones, all laptops, electronics. These are the different applications area. When it comes to power electronics, we are using with the high power application, mostly in the power systems. So that is the reason we are using power electronics devices. And what are the key components of power electronics? So power semiconductor devices, converters, control circuits, passive components. So we heard about the controller converters like DC to AC, AC to DC converters. So where we usually apply, this is what I am talking about, the majority of the application come to the power system in the transmission of distribution of power. Okay, these are the devices. Okay, power semiconductor devices. These devices handle high voltage and current and switch or control the flow of power. So these are the power semiconductor devices. So we need to pass a power system engineers. We need to focus on studying about power semiconductor devices. So these are the tires like SER, GTO, power transistors, not the simple transistor. These are power transistors, IGBT, MOSFET, BJT, then triac. So what I'm talking about is a high voltage, high current uh, handling capacity of these devices. I mean, these devices having the current carrying capacity, which is very high current and high voltages. Okay, and then consider about converters. Power converters are circuits that transform electrical energy from one form to another. So these are rectifiers from AC to DC, inverters DC to AC, and choppers DC to DC, and AC controllers AC to AC. So we studied in solar PV system, we need inverters because whatever we generate solar PV, we had to invert it as a AC signal, and we had to send to grid, export to grid. So these things, the solar panels output voltage, all these things, dealing with these things is a high current application. So this application is about supporting to electrical power system. So power system, we have a power flow from power flowing from one place to another place, sometime from grid to house, sometime from house to grid. If you have a solar PV, if you have excess power generation, is a reverse power flow. So all sort of things we are using the power electronic devices. So then we have a control circuits. These circuits regulate the performance of power electronic devices and ensure desired output. So we have the control circuits in power electronic devices to regulate the performance of that particular device. So that's a, we usually have a control circuit. You can see control circuits in power electronic devices. And we come to the last slide. We have a passive components. Okay, so in power electronics, we need to study about passive components, basically inductors, capacitors, and transformers for filtering and energy storage. So we know that we are using inductors and capacitors for many applications. For capacitors, for filtering, inductors, many applications, like even we use capacitor for increasing controlling the power factors. So whenever the power factor issues come, we increase or reduce the capacitor size. So capacitor and inductance are playing a major role in controlling the power system parameters, basically impedance, power system impedance. Because so this is also one of the power electronics. When we study about power electronics, we these passive components like transformers, inductors, capacitor, resistors, these all play a major role in this power electronics devices. So we almost come to the end. So what is the understanding? Because when we students are studying about power electronics, basically like they don't have much idea. They started to do a lot of calculation, but they have to understand why they are studying power electronics. If let's say someone, they don't want to work in the power sector, then there's no need to study the power electronics. So that's just my simple opinion. So if someone wanted to work in a construction industry as an electrical engineer who is want to do the wiring diagram, electrical wiring, switchboard diagrams, and sort of thing, there's not much requirement to know about power electronics. So in other hand, if someone want to work in the power sector as a power system engineer, so there are different job position in electrical engineering, basically. So electrical design engineer, we usually consider electrical design engineer mean basically he's designing many things, basically construction related electrical building, electrical wiring diagrams, all sort of things. When it comes to power system engineers, he is targeting on working in the power sectors, transmission and distribution, power generation. So those people need the knowledge on power electronics. Thank you very much. See you in the next video.